Thank you. I hope you all had a good intermission. Got a new drink.
Here we go. All right. Hey, I am Dr. Brian Mulligan, also known as AstroBit.
That sounds nice.
I like it. I like it.
And I am just normal Sinclaire Manning.
She'll be a doctor soon.
Soon. Also known as Major Merger. And here are the month's top news stories in astronomy.
Nope. Other one.
Boop. All right.
There we go.
So.
I'm a doctor. I can't figure out, devices. That's.
Okay, so new observations by 3 of the world's largest radio telescopes have revealed that an asteroid discovered last year, known as 2017 YE5, is actually 2 objects, each about 3,000 feet in diameter, orbiting each other. So this is only the 4th equal mass binary near-Earth asteroid ever detected, and the 2 asteroids that make up 2017 YE5 orbit each other every 20 to 24 hours. So NASA announced the new findings on July 12th, and along with the fact that there are 2 bodies, not just one, the asteroids continued to surprise astronomers by not appearing to be identical. So based on the brightness of the asteroids, it appears that they may be varied in composition and perhaps have extremely different textures. They do not reflect as much sunlight as a typical rocky asteroid would, and are likely as dark as charcoal. So on June 21st, the asteroids made their closest approach to Earth, flying by about 3.7 million miles away, so we were safe from them. But they were discovered by NASA's Goldstone Solar System Radio in California, the Arecibo Observatory in Puerto Rico, and the Green Bank Observatory in West Virginia. But unfortunately, it may be a while before any new observations can shed more light onto this pair, as the asteroids won't orbit this close to Earth for another 170 years. Aww. But it was nice to see them while it lasted.
I like that they try to match our day. Yeah. 24-hour period.
Yeah.
Okay. Let's see. Can I go on the right? No!
New clicker, man.
There we go. Okay. All right, now the bad news for the month. JWST is delayed again. So James Webb Space Telescope, the next generation infrared telescope commissioned by NASA, has been delayed. The original plan was to launch in 2007, already 11 years ago. It can't be fixed or replaced once it's in orbit. So it's very important to get everything right before it goes up. Obviously, they didn't hire Gordon to work on it. So delays during the design, construction, and assembly had already pushed the date back to next year. Now, the newest issues and delays have pushed the date back to 2021. Or, according to XKCD, what was it, 2026?
Yeah.
26, yes. So it's undergone testing over the last 2 years. Problems were recently discovered in the last couple months with the sun shield and a fuel valve, and I think another problem just cropped up in the last couple of weeks. NASA established an independent review to consider what work had been done, what potential problems could still crop up, and the process and methods that were being used to evaluate everything that was going on. The review board essentially determined that more review and testing is necessary, which is why it's necessary to push the launch date back to 2021. The board recommended several administrative and procedural changes for the project, but concluded that the project should continue and is vital to the future of astronomy in the U.S. Unfortunately, the new delay is going to increase the cost of the project to about $8.8 billion. Only $800 million, not much, $800 million more than Congress is maximum authorization for this project, which means it's going to have to go back to Congress now to get authorization to continue. So email Ted Cruz or Beto.
Hopefully Beto. Yeah!
To get that done. All All right, so the James Webb Space Telescope, for a little background, it's an infrared light telescope. It's sort of a successor to Hubble, but not quite a replacement. It's going to allow for the highest precision ever in exploring planet formation, look for signs of life on planets in our galaxy, and study stars and galaxies as they were in the first hundreds of millions of years after the Big Bang. Hey, we got it right this time.
So, a never-before-seen image has been taken showing a newborn exoplanet taking shape in the disk of gas and dust surrounding a young star. So this serves as the first direct observation of such a young exoplanet. Up until now, it's been difficult to differentiate between what may be a young exoplanet versus what's just normal features in a debris disk. But Miriam Kepler, the discovery leader at the Max Planck Institute for Astronomy, and her colleagues analyzed new and archival observations of the young dwarf star named PDS-70, which is about 5.4 million years old and 370 light years from Earth. So if 5.4 million years doesn't sound that young to you, just remember that our sun is 4.5 billion years old. So in terms of star formation, it's pretty young. So, the observations taken at the Very Large Telescope in Chile and the Gemini Observatory in Hawaii show a gas giant in PDS-70's surrounding protoplanetary disk by using coronagraphs, which block out the light of the star, which you can see in the middle of the image. That black circle is where the coronagraph is, which allows for the dim planets, which is down in the right corner, to be resolved. So Kepler and others like postdoc Andre Müller, or if someone who knows German can say that better than me, Müller. Also at the Max Planck Institute have determined that exoplanet, or PDS-70b, to be 2 to 3 times bigger than the mass of Jupiter and 1.9 billion miles from the host star, which is roughly the distance from the Sun to Uranus. So PDS-70b is much hotter than any planet in our solar system, though, with an average temperature of 1,800 degrees Fahrenheit, which matches up well with other newborn gas giants. But according to Kepler and Müller, this discovery offers a new window into the complex and poorly understood early stages of planetary evolution. Nice. Wow, this crowd is so supportive tonight. I love it.
Yeah, I like it. Good crowd. Thanks for coming. All right. So a study of rivers on Mars found that the planet must have had rain sometime in its very distant past. The study was led by Hans-Jörg Sebold, a researcher at the Swiss University of Technology in Zurich, and whose name I just find fun to say, Hans-Jörg. Hans-Jörg and his team reviewed the dry riverbeds on the planet and compared how the water flowed and the rivers merged with how similar phenomena occur on Earth. So Hans-Jörg looked at rivers in Florida and rivers in Arizona and New Mexico, essentially a very wet climate where the Florida, where the rivers form from groundwater swelling up from underneath, and Arizona and New Mexico, where the rivers form from rain falling in a dry environment. Hans-Jörg concluded that the angle between the tributaries is large for rivers that are a result of groundwater, like those in Florida, and so therefore the rivers on Mars, the rivers on Mars do not exhibit such large angles, and so the rivers on Mars must have been caused by rainfall. This is exciting. The rains on Mars probably stopped only a few hundred million years after the formation of the planet due to the loss of the atmosphere, but the presence of rainfall suggests that there was a water cycle on Mars, meaning that there's a much higher probability for life during that very short time period, and it offers possibilities for finding life perhaps below the surface even now, or at least remnants of life. So very, very exciting, and one more time, Hans-Jörg.
All right, so astronomers have traced a high-energy neutrino to its source for the first time ever, and it's kind of a big deal. In case you've never heard of a neutrino before or just need a little refresher, neutrinos are nearly massless subatomic particles that have no electric charge and therefore rarely interact with surrounding matter. In fact, trillions of these so-called ghost particles stream through our bodies unnoticed every second. So you have a bunch of neutrinos flowing through you right now, and you have no idea. It's kind of cool. So most of these neutrinos come from the sun, but a small percentage of highly energetic neutrinos rocket towards us from way out in space. But because they're so elusive, it's been extremely difficult to pin down the origin of these cosmic wanderers until now. Researchers at the Ice Cube Neutrino Observatory in the South Pole have successfully traced one cosmic neutrino out of trillions to a distant quasar. Oh, sorry, blazar. Blazar. They're different. So yeah, if you don't know what a blazar is, that is a huge elliptical galaxy with a fast-spinning supermassive black hole in the center. But wait, there's more. So since neutrinos go hand-in-hand with cosmic rays, which are highly energetic charged particles that continuously slam onto our planet, but luckily we're protected by our magnetic field, astronomers have concluded that blazars act as accelerators for at least some of the fastest moving cosmic rays as well. So Francis Halzen, you can see in the bottom right, is the lead scientist at the Ice Cube Neutrino Observatory and professor of physics at the University of Wisconsin-Madison. Woo! Our Wisconsinites out here. He said researchers have been looking for the source of cosmic rays for over a century, and now they finally found one. So now Ice Cube is not your typical observatory. So besides being at the South Pole, the facility consists of 86 cables, which you can see in the diagram in the middle here, which extend down into boreholes about 1.5 miles deep into the Antarctic ice. And you can see the Eiffel Tower on the bottom right here for scale, how many Eiffel Towers tall it is. Yeah, wow. So every cable then has 60 basketball-sized digital optical modules, which are outfitted with sensitive light detectors. And these detectors are designed to pick up the characteristic blue light emitted after a neutrino interacts with an atomic nucleus, and all the overlaying ice prevents particles other than neutrinos from reaching the detectors and dirtying up the data. So can you click to the next slide? Actually, I have another slide. That's how much we needed for this one. So here's a neutrino event as people working on Ice Cube see it. So this one displays a muon, which is created by the interaction of a neutrino with the ice close to Ice Cube, which then leaves a track of light while crossing all those detectors. And in this display, the light collected by each sender is shown in one of the spheres. And the color gradient from red to blue shows the time sequence. So it's like coming from the blue to the red, and the bigger the sphere, the more energy. So these are very rare events, and Ice Cube spots just a couple hundred neutrinos per year, with the first extragalactic neutrino detected in 2013. This newest detection was measured to be extremely energetic, packing about 300 tera-electron volts, which... Yeah, you didn't even know that one.
That's huge.
If you need a reference, that's nearly 50 times greater than the energy of the protons cycling in the Large Hadron Collider. So that's a lot of energy. So, nearly 20 telescopes on the ground and in space, covering gamma-2 radio waves, then search the sky to find the source of the neutrino. And this marks another successful use of multi-messenger astrophysics, or the use of at least two signals to understand the same event. So anyone who knows about our neutron-neutron collisions, all our LIGO detections, that multi-messenger astrophysics is becoming a big deal now. So each messenger, from electromagnetic radiation to gravitational waves, and now neutrinos, provides a more complete understanding of the universe and new insights to these phenomenon. Whew. Okay, thanks for sticking with me on that one.
Good job.
We need a whole talk on Ice Cube and
yeah,
neutrinos.
I think that deserves its own talk. We'll have to find an Ice Cube person to fly somebody up from the South Pole to talk about it. Yeah. Okay, so our final story is what we call Astronomy Not in the News. This is where we highlight a story that's generated a lot of discussion within the field of astronomy, but hasn't necessarily made it into mainstream news sources. So this month, we're talking about research done by a team led by Catherine Fisher, who's a graduate student at the University of Pittsburgh. So in light of recent measurements of the properties of our own galaxy, Catherine and her team set out to investigate how the properties of galaxies affect how many small satellite galaxies orbit galaxies like our own. So one of the problems that we have with our galaxy is that we find a lot fewer galaxies orbiting it than we'd expect there to be. So they specifically investigated how dark matter density, so kind of sort of illustrated over here on the left, something that's really dense versus something that's really fluffy in the same radius. Also the size of the disk, so here's something with a large disk and something with a small disk. And then the shape of galaxy, which I don't have a thing for, and then how long it's been since a galaxy merged with another galaxy. So an example of a big galaxy merging with another galaxy that's, in terms of mass or light, about the same size. So they looked at how these parameters affect the number of satellite galaxies, and they found that the density of dark matter and the size of the disk, these factors here, have the largest effect on how many galaxies or how many small satellite galaxies are around any particular Milky Way light galaxy. Our Milky Way has a very, shoot, I forgot to write it down. I think our galaxy has a very low density and small disk, which leads there to be far fewer satellite galaxies around our own than is average for Milky Way type galaxies. So this helps explain why we don't find as many of these smaller satellite galaxies as we expect there to be. It helps explain a long-standing problem in astronomy. Most models predict a lot more galaxies, but these models essentially rely on the average. We are clearly not an average galaxy in those terms. So Catherine's work is not the complete or only answer to the problem, but very much helps fill in the picture for this.
All right.
All right.
Thank you all for listening.
Thank you all for coming.